The study was conducted to test how enhanced mood during exercise can increase the likelihood of physical activity in the future. So researchers rated mood after 6 months of physical activity, so that's shown in this part of the table, and then again after 12 months. And it was rated on a scale of -5 to +5. Assume that the data are normally distributed. And the reason that this statement is really important is because we're going to start with a sample of size 5 for our first example. Now remember, according to the central limit theorem only, quote, works. In other words, we're only assured we have a normal distribution if we have a large sample size. However, if we know that the original population is normal, then we don't care what the sample size is. The sample size can be small. It won't matter. We will still have a normal distribution for the sample means. Okay, so it says, what is the probability that a sample mean for a sample of size 5 selected from the population would show no change or a negative change after 6 months, or again after 12 months? So let's take a look. Now, because our parent population is normally distributed, we know the sample means are going to have this shape. And we're going to start with the 6-month picture first. So we know that it's going to have this shape. It's going to be centered at the same place that the original population was centered. So in other words, it's going to be centered at 3.3. However, the spread of this distribution is not 1.2. According to the central limit theorem, the spread is going to be 1.2 divided by the square root of the sample size. In other words, 1.2 divided by the square root of 5. So let me grab a calculator and do this calculation quickly for us. So if we take 1.2 and divide it by the square root of 5, we get 0.54. So we know that the spread of this distribution is 0.54. And we want the probability that the sample mean is going to be 0 or less, no change or negative. So 0 would be over here. So we're looking for this area. And how would we find that area? We would go to an online statistical calculator and do that calculation. So to save time so that we don't have to switch the online calculator and all of that, let me just do that for us. So we would go to a normal distribution, and we want to have a mean of 3.3. The spread of this is 0.54. And so this would be about 0. This area here would be approximately 0. Okay, it's a very, very small probability that after 5 months or after 6 months you would find that change. Okay, let's take a look at the second question. It says, what about if we did the picture for 12 months? All right, so the picture for 12 months would look like this. Even though the sample size is small, we know it's going to have this shape because we're drawing from a population which is normally distributed. The mean is going to be 3.3, but the spread of this curve is going to be the standard deviation, which is 1.3, divided by the square root of sample size. And in this case, our sample size is still 5. So the spread of this distribution is going to be 1.3 divided by the square root of 5. Let me try that again. So 1.3 divided by the square root of 5. Try it one more time. My calculator is not, it's doing what I'm asking it to do, which is not what I'm trying to do. Okay, 1.3, now we have it. 1.3 divided by the square root of 5, that turns out to be 0.58. Okay. So again, we want the area here at most 0 or less. So that's this area here. And let's take a look at what that would be. And again, this would be an online calculator. So you could practice your online calculator skills by going to the online calculator that we referenced earlier and entering these values. And this one also turns out to be approximately 0. Okay, so it's very unlikely that in either scenario you're going to have no change or a negative change. So in other words, under both scenarios, 6 months out or a year out, 12 months out, the people tended to have a much more positive attitude towards exercise, being more likely to keep on exercising. Okay, all right. It says, using the previous example, how would your answers change for samples of size 20? Well, we could do the calculation again, but let's just think about that in a picture for a moment. Do you remember back here, this is going to make you a little dizzy, so if you want to look away, feel free. But do you remember when we first started talking about normal distributions? This picture here. So what happens, these are values that have the same center, but different spreads. See that? And this spread, just as it got skinnier, standard deviation got smaller, the spread got skinnier and skinnier. Do you remember that picture there? So if we were to do, and again, look away if this makes you a little dizzy as I scroll through the notes. Okay, so if we were to do samples of size 20, again, the mean would stay the same and the shape would stay the same. It would still be here centered at 3.3, but now we're doing the standard deviation, no matter if we did the 6-month picture or the 12-month picture. Let's just do the 6-month picture. But now we would be dividing by the square root of 20. So even though I draw them the same way every time, what happens is that the values, the pictures, this is super hard to draw, so just bear with me. But if you divide by a larger number, the standard deviation, the spread of your curve just gets narrower and narrower. And so if you were to do samples of size 20, you would do it exactly the same way, except you would be working with a curve that was skinnier than your original one. Okay, well, that was the central limit theorem and our lecture for today.